showcases some of the outstanding talent operating in our consular region. We thank wholeheartedly Cinzia Zuffada, the president of the Italian Scientists and Scholars in North America Foundation, and Maria Teresa Cometto, who will act as a facilitator. Our guest tonight is Professor Antonella Nota, Hubble Project Scientist and European Space Agency Office Head at the Space Telescope Science Institute in Baltimore. She is going to entertain us with a spectacular series of slides and insights. Before starting, I wanted briefly to linger with you on the Italian excellence in research and in particular in space science. Why are Italians able to team up with the #1 world power for space? Now, you need to know that Italian researchers rank number 8 in the world for number of international publications and number 5 for number of citations. More specifically, Italy ranks number 2 in Europe for the number of awards granted by the European Union. As regards, in particular, space cooperation with US, most significantly, on September 25th, an agreement was signed between Rome and Washington in order to associate a new mission tasked with creating the first human base on the moon. Italy was 10 billion euros to provide innovative technology for the lab, for the landing hardware, for the telecoms, and for the building of the modules of the new base. Concerning the Hubble and James Webb telescopes, Italian technology and Italian scientists have contributed to their construction. Hubble, the scientific input and financing by the European Space Agency, and has been made possible, among others, to measure the estimated age of the universe, to study the formation of galaxies, and to present us with far more detailed and clear images. Now, a very hot news that I read yesterday on the newspaper Corriere della Sera also says that Italian radio telescopes have been able to register the remnants of a star which is placed thousands and thousands of light years away from the Earth for the first time of the human history, and that will help us understand how these particles fly in the cosmos. I thank you again for your presence, and without further ado, I will give the floor to Cinzia Zuffada. Thank you very much.
Thank you, Consul General Forlano, for your kind introduction and for hosting today's event together with the IIC of New York. We are really honored to have the opportunity to introduce ISSNAF to the Italian community in Pennsylvania, historical Philadelphia, everywhere else where the audience is tuning in from today. We represent the network of Italian researchers in North America, whose mission is to help connect our members across discipline boundaries, to serve as a resource to our communities, highlight the outstanding accomplishments, and in particular help the younger generations of Italian researchers to succeed. As Italian, we share common experiences in our professional trajectories in the US, and also a common identity. And so we are all well equipped to come together and want to congregate with one another and feel the spirit of a whole community. We hope that by sharing what we do with all of you, we can provide an enriching experience for the public and one that helps foster a sense of community. And in fact, if you haven't done so already, you are all most welcome to join ISSNAF and get engaged with us. It is now my privilege to introduce Maria Teresa Cometto, an Italian journalist based in New York since 2000. She writes about economics, business, technology for the leading Italian daily Corriere della Sera, and is also the author of several books. And enjoy. Thank you.
Thank you. Thank you, Cinzia, for your nice introduction. Thank you to ISSNAF for asking me to participate in this wonderful event. Thank you also to the General Consul in Philadelphia. Hi, everybody, and thank you for following us. Antonella, it's so great, it's really fantastic to have an Italian woman as one of the top scientists working for the Hubble Space Telescope since the very beginning of this mission that is 1990. Antonella, you are an astronomer, so you must be very excited about today's news that the Nobel Prize for Physics was given to 3 scientists who worked about the black holes. Your Hubble Space Telescope has done a lot of work also on the black holes, right, Antonella?
Absolutely. And I want to make sure that you're seeing my screen first. You should see that this year for us, in addition to the Nobel Prize that we will discuss in a minute, it's also key because we celebrated 30 years in orbit of the Hubble Space Telescope. But let's talk about the Nobel Prize. Every time we hear the Nobel communications, our heart goes faster. And this is because we hope that astronomy and astrophysics is rewarded once again. And we were absolutely delighted to see 3 prominent scientists getting this prestigious prize this year for their work on black holes. So these were Roger Penrose, Rainer Genzel, and Andrea Goetz, which, we have to highlight the fact that Andrea is the 4th woman to get a Nobel Prize in physics. So, Maria Teresa, you asked me what Hubble does for black holes.
Yeah.
It has done quite a lot, but I can't show you a pretty picture for black hole. And the reason why that Hubble, to study black holes, needs spectroscopy. Now, this arcane word. So spectroscopy is that phenomenon when you have a beam of light and you pass it through a prism or a grating, and the light is dispersed in all the possible components. This information for astronomers is key because we can see exactly what are the properties of the emitting light. And so for black holes, this has been key because we could measure the motion of the gas and the dust and the material very close to the black hole itself. And what you see here in this graph, you can see the blue part, which moves towards us, and the red part of that curve that moves again, away from us. And this is what astronomers call red shifted and blue shifted at incredible velocity. So, for example, this is M87, a galaxy quite close to us. Our own Milky Way has a black hole at the center. We call it a supermassive black hole because it's 1,000 times the mass of our sun. We don't see it, but what these scientists did, who got the Nobel Prize, they characterized the black hole just looking at what happened around it. So a phenomenal discovery, and we're just very, very delighted to see it rewarded.
Yes, fantastic. So the telescope and its discoveries are important for physics, are important for our most profound philosophical questions. Where do we come from? Are we alone in the universe? And they are also important for artists. I know that you, Antonella, are a great advocate of the collaboration between scientists, astronomers like you, and artists. And you have collaborated with artists for installations using the beautiful images taken by the Hubble telescope. Can you give us a couple of examples of how these images have been used by artists in Italy and everywhere in the world?
Absolutely. It's a pleasure. Yes, we realized, so Hubble, as I said, has been in orbit for 30 years. And we realized that when beautiful pictures appear in the magazines and in the press and on TV, we realized that these beautiful pictures, like, for example, this one, the Bubble Nebula, they were able to connect with people in a way that was very different from the connection with the scientists. Scientists look at this image, or, for example, this other image, which is a star-forming region. So if I look at this image, it's beautiful. But what this image tells me is where are the stars that are forming. This is a nursery of stars. We can see where the newborn stars are emerging from the cloud, the cocoon, or gas and dust. When you look at this, I hope, it has a connection, a deeper connection. It speaks to people's soul. And we realized this over the year, that it triggers all sorts of interesting thoughts and imagination about also our presence in the universe, where we are, where do we come from, what is our origin, what is going to be our end. So, for example, in this image that you can see here, we call it the pillars of creation, because again, we're looking at the part of the sky where you see stars being formed. So what is interesting of this view? You see two images next to each other. One colorful and full of puffs of smokes, of dust and gas. The other is peppered with stars. Well, we are looking at this same object in two different wavelengths. And so in the visible to the left, it's opaque. You see the clouds of dust that actually form the stars. To the right is in the infrared. You can go through the clouds and see the stars. So this for us is amazing. But these images are so beautiful that they speak to people in a completely different and more profound way. This is my favorite. I took this 5 years ago, and it's another star-forming region, really beautiful in our Milky Way. And finally, just to answer your question, Maria Teresa, this is a planet. This is Jupiter. We all know Jupiter. We've seen 1,000 beautiful pictures of Jupiter. You probably have never seen one like this, because in this one, it's a composition of an image taken in the visible, so where the eye can see, with an image taken in the ultraviolet, which is outside the range that our eye can observe. And the little cap that you see, the purple cap on the top, is an aurora, exactly like it happens on our own planet. So when we show images like this to artists, they get inspired. And for example, they come up with ideas like this. This is Maria Luisa Taddei interpretation of a planet picture. And she did this. This sphere is actually pretty big, with mosaic in the Byzantine tradition to highlight, the contrast and also the little tassels that are part of this beautiful ensemble. We ask an artist, this is Mario Paschetta, we ask an artist to imagine how a planet outside our solar system would look. And we told him, we would like you to think about a planet that cannot host life, a cold, icy planet. And so he came up with this beautiful, large painting, which has also something very interesting that I want to share with you, very unique. If you look at the bottom right and you see fragments of metal, those fragments of metal were actually on the Hubble Space Telescope at the beginning of the mission for 3 years. And they've been integrated in this picture almost to signify that on this inhospitable planet, a spaceship has crashed and burned because it's so inhospitable that nothing survives. So this is that I'm showing you are scenes from Our Place in Space, which is an art and science exhibit, which we showed in 4 or 5 different cities in Europe with great success. I worked with an art curator, Anna Caterina Bellati, and the beauty is that every object that you look in the sky has a possible, artistic application. This is the Whirlpool Galaxy, which is truly spectacular. You can see all this garland of stars and clusters forming where the gas is richer, where the star is denser. And this basically inspired Sara Teresano, a sculptor, to produce this beautiful piece that was also shown at Our Place in Space. So I hope I answered your question.
Yeah, beautiful indeed. But let's go back to the science side of the Hubble Space Telescope. Why is it a special telescope, and why is it?
I think I missed your last question, but I think you want to ask me why it is so special and who is it named after. So it was named after the famous astronomers of the 50s, Edwin Hubble. Edwin Hubble was the astronomer. You can see the old way to do astronomy, sitting at a telescope in a dark night, cold night. Here, Edwin Hubble is portrayed while he made this major discovery of the fact that the universe is expanding. And because one of the theme of Hubble science was study the distant universe, people felt at the time that it was really appropriate to name it after Edwin Hubble. So Hubble it is.
Yeah. Can you hear me now? Can you?
Yes.
Antonella,
yes,
hear
I
me?
can.
Okay.
Yes, I can hear you now.
Yes. Europeans are involved in these projects. Can you explain how, and can you explain your own role in
Absolutely.
project?
So Hubble was launched in 1990. But as I said, we just celebrated the 30th anniversary and all these beautiful pictures that people, are seeing and enjoying. So Hubble was launched in 1990. The collaboration with the European Space Agency on this mission started in 1975. If you think that the European Space Agency actually formed in 1964, this was a very, very bold move for this young agency to get in a collaboration with the big guys, with NASA, to produce these space observatories that people wanted really to see in orbit. So ESA has been a very faithful partner since 1975. I joined the project much later, but I have enjoyed every moment of this. And we still have 15 people sent by ESA to Space Telescope Science Institute, and I'm the head of that little contingent. And we're supporting Hubble, and we're also supporting the European community in Europe, so that the community in Europe feels that they are engaged at the same level of the US community. And this has been extremely successful. We have something like 3,000 users in Europe, that for an astronomical mission is quite big. And European astronomers are very, very creative and are very successful at getting Hubble time.
Yeah, Antonella, what about your own passion for astronomy? Why did you decide astronomy and graduate from astronomy from the University of Padua? What triggered your passion?
Well, being honest, I've been passionate about astronomy since I was a kid. And what you see here is, in a sense, is a copy of my own journey. When I was in Italy, Venice was the center of the universe for me. And then I moved out, went to Padua to study, then moved to Germany as part of the European Space Agency, then left Italy, went to the US. But as I said, I started as a teenager. I was fascinated by the night sky. As a matter of fact, I was the second female observer to participate in observation of variable star from Venice. I would be outside on the, sorry, I'm trying to get rid of this, on the beach at the Lido with my binocular, trying to measure variable stars, making all my friends laugh. But that has been, that was just the beginning.
Okay, so you joined the Hubble Space Telescope from the beginning, but at the beginning it was not a complete success. There were problems, there was trouble. And 1993, the problem was fixed by the astronauts going there by the space shuttle. And I understand that one of the special feature of this telescope is that it is built to be maintained human beings. Can you recall that first mission to fix the problem?
Absolutely. I can tell you a little bit of a story because in a sense it's also my story. I moved to Baltimore in 1986. At that time, we were supposed to launch basically a few months later. For some reason, this is now stuck. So let me just try to see why. Sorry. Oops. Something happened. Let me open the presentation again. Let's see if we can recover because I want to show you the beautiful pictures that are coming up. Yes. Okay, let me just bear with me.
Okay, we can watch you and you can go on talking in the meantime.
I can continue talking, and I can tell you that basically in 1996 I moved to Baltimore, and I was in the auditorium when, unfortunately, let me just stop sharing the screen for a second. I was in the auditorium when the Challenger disaster happened. And that was just so heartbreaking for all of us. I just arrived in the US. I hoped that at that, this was supposed to be my career. We were going to launch in a few months, and then the Challenger disaster happened. And so at that point, we were, it was the 3 years of, let's say, incredible sadness because we had waited for this launch so much, and we had to wait another 3 years. But then eventually we saw it, and the anticipation of waiting for the first image was incredible. We were just hoping in the quality and in the excellence that we had worked so hard to see. But unfortunately, that was not the case. The images were okay. We still could see that they were an improvement over the ground-based image, the images that you could take with a regular telescope. Can you see my screen? Do you see my screen now?
No.
Oh, okay.
No, we don't.
Oh, okay. Hang on a second then. Okay, it's easy. This is easily fixed. So
please go on, Antonella. We are following your story.
So the images were.
And in the meantime, excuse me.
Yeah.
In the meantime, I want to tell all our audience that you can send your question application, and we will answer your questions at the end of this little talk.
You should see my images now. Yes. Yeah. So this is So this is what we saw at the beginning. So you can see that the images were okay. You could see stars, but they were not as sharp as we would have hoped. And at a careful looking, they were horrible. The images were absolutely horrible. They looked like this. A point source looked like a crab. And everybody was in total despair because suddenly everybody's dream collapsed. Of course, the cartoons started. At that point, the press, the media, after investing so much, they would not spare, the comments. We saw all this appearing everywhere. And for us working on the project, it was really, really a bad moment. Also because I had left Italy to come to the US, hoping to build my career on this. So after 3 years, finally, engineers and scientists across the pond in Europe and in the US work together to come up with a solution. And we owe the solution to our heroes as the astronauts, because as you said, Maria Teresa, the Hubble was designed to be refurbished in space. So astronauts would go up with the shuttle and would work on the telescope, like doing maintenance work, like you would do in your backyard with the knees that we were. So yes, I do remember that first servicing mission. We were all in the auditorium holding our breath. And it was just watching a thriller in slow motion and watching them work and installing the corrective optics was just, that's a feeling that I will never forget. And we have been welcoming this amazing crew of astronauts back at our institution over and over and over because, and they tell us that they are so pleased to see how their work resulted in the amazing science that this telescope has. So this is a snapshot from one of the servicing missions, the very first where they installed the corrective optics. And so then we see the first image and we see, so this is what we were seeing before the correction. And this is what we saw afterwards. So everybody went into a big array because the telescope had been fixed. And the famous Senator Mikulski, senator from Maryland, declared the trouble with Hubble is over. And she was the one that had called Hubble, we still laugh about it, a techno-Turkey, not, a few months before. So the rest is history. The telescope has been taking spectacular images and making, breakthrough discovery in pretty much every field of astrophysics. So we could not be more privileged.
Thanks to the discoveries made by the Hubble Space Telescope, we have changed our view of the universe. So can you mention the most important discoveries made with your telescope and what has changed in our universe?
Yeah, I give you a flavor of different things because Hubble has such a set of instruments that is so versatile and powerful that a lot of discoveries have been made in many different astronomical fields. But for example, one of the important things is studying the early universe. That was Hubble was designed to do. And in the 1990s, as you can see from this graph, we could look only halfway through to the distance where we look today. So if we imagine that the origin of the universe is to your right, in the sort of blurry part, Hubble, from the ground in the 1990s, we could see probably to a distance of 6 billion years. Remember that for astronomers, time is space, because when you look farther away, you're also looking back in time. So 6 million years. And then the first big discovery was the Hubble Deep Field, where Hubble looked at the pencil beam, small piece of sky where from the ground you couldn't see anything. It was completely dark. And then when Hubble took that very, very deep exposure, keeping the telescope pointed on that space for several days, we realized that it was peppered with distant galaxies. And so we realized that the universe was full of these small galaxies. And as you go back in time, they were looking different. They were looking very different from how they look today. And if we look, so we pushed and pushed and pushed. And now I think we have reached the limit of what Hubble can do. But James Webb Space Telescope that will launch at the end of next year will push that boundary even farther, and we'll go to the very, very beginning, 13.8 billion years ago, to see the first stars and the first galaxies. Other example, so to me, one of the biggest discovery is the discovery of the accelerating universe. So Hubble was set to observe the expanding universe as it had been discovered by Hubble, but in reality, Hubble did some more. Together with ground-based telescopes, discovered that the universe not only is expanding, but is accelerating. And we did that. This was also, I think, the one Nobel Prize that Hubble got with Adam Rees and other two astronomers who basically looked at far supernova. Supernova are stars that explodes and basically disappear. But they have a very, very characteristic signatures. You recognize where they are, even if they're far away, even if you don't know their distance, you can infer their distance from the profile of the dimming of the light. And so it was realized that basically because of the distance of this supernova and their position in the universe, that they were actually, the universe is expanding. And why is expanding? Because there is a force that we call dark energy that is kind of, pulling from the outside. What is dark energy? We do not know. Astronomers immediately jump to the opportunity to design missions to characterize dark energy. Another example is the impact of a comet on Jupiter. This was one of those transient events that happen once in a lifetime. But Hubble was able to take images of comet Shoemaker-Levy in 1994, actually entering Jupiter. You know that Jupiter is not a solid body. Well, there is a solid core, but it's basically a thick atmosphere. And what we see in these beautiful, bands and spots, they're storms that are happening in that atmosphere. And so you see here an impact caused by this comet just plunging in. The beauty of this work that it allowed astronomers to figure out exactly the stratification of that atmosphere, and tons of papers came out of that particular. One close to my heart, the discovery close to my heart, is discovery in a field for which Hubble was not designed. When Hubble was launched, we did not know that there were planets outside our own solar system. The only planet we knew were the planets we know: Mars, Venus, Jupiter, Neptune, Pluto, who is not a planet anymore, but we will not go in that conversation. So we didn't know that there were planets outside the solar system. Then, as science progressed, it was discovered that pretty much every star has planets around it. And so Hubble has started characterizing their atmospheres. Like this, for example, system, TRAPPIST, you probably have seen it in the news. TRAPPIST is a system that was discovered by a ground-based astronomers. And it's a system, a small solar system of Earth-sized planets. So what is the big question? Would any of these Earth-sized planets could be like Earth and observe and have host life? And Hubble has been studying the atmosphere. So this has been a crucial work of Hubble in the past few years. And last year, there was a result of which I am exceptionally proud, which is the discovery of water vapor, not in the TRAPPIST system. This is Kepler 218b, another exoplanet that has been studied by Hubble. This is what you see here is an artist impression. We would love to, at some point, to have a mission that can actually take a picture of an exoplanet, but the discovery that there is water vapor, as you know, water is one of the building blocks for life. So this is something that has energized this field tremendously last year. I think, okay, I think, yes.
So talking about water and also other chemical substances that can be a sign of life, what do we know from the telescope, from the Hubble telescope? Are there really signs of life somewhere in the universe? For example, astronomers recently discovered a chemical substance on Venus. What can you say to us about this?
So the discovery of phosphine has been incredibly interesting. And immediately astronomers started wondering, well, can we find phosphine in one of the other exoplanets that Hubble has studied? No, with Hubble. We basically cannot do it with Hubble because it falls outside the wavelength regime that Hubble can observe. But it can be done with the James Webb Space Telescope. So that's why I put the picture here, because this is what we hope will replace Hubble in the hearts and minds of people when it's launched next year. We're so excited by this new mission that will open completely new windows into our universe. And one of these new windows will be exactly to look for the building blocks of life. So not only water, but methane, complex molecules. So stay tuned, because this will be the phenomenal science that you will see coming from space in the next few years.
Will it be launched next year?
Yeah, at the moment, October 2021.
Oh, great. So in 1 year, we will be back maybe to talk about it.
I would be delighted, yes.
Yeah. Well, you are one of the few women in this field. I read some numbers saying that women make up only about 15% of astronomers worldwide, and only 5% of full professors in astronomy in the US, US universities, are women. And I suspect that a similar situation is true in Italy too. How can you encourage more women to study astronomy and have a career in this field? I know that you have done a lot of work to improve this situation.
Yes, I actually think that, for example, this is an example of a program that we started several years ago. It's called Caroline Herschel Visitor Program. I think the issue is role modeling. Young women researchers need to be mentored and have role models that they can relate to. And so we started this program, and we invited, successful women scientists to come to STSCI and work with our young researchers and mentor them in their career, help them, because it's hard to navigate a workplace where that is still, male dominated. So I think the situation is improving. When we started this program at Space Telescope, it was just 2 women on the science staff. I was one of them. Now we're 54. And so I think it's important, role modeling, mentoring, coaching. And I want just to make a plug for ISSNAF here, because ISSNAF has just started a mentoring program exactly to connect young, promising students and researchers in Italy with colleagues here in the US to try to navigate this career jump if they're interested, for example, to come to the US and study and follow our tracks in establishing a career here. So mentoring is a very, very important part of what ISSNAF does. And in addition, we are now running exactly now the Young Researchers Award, which will highlight and give visibility to young Italian research, including, many women, for their work, for their brilliant research. So I think, yes.
No, thank you, Antonella. I'm told that in 10 minutes we have to finish this great conversation. So I invite again our audience to send their questions through the app. So waiting for questions from the audience, I'm asking you to tell us something about Italian astronomers. Italians have been historically very good in this science, right? From Galileo with his first telescope to today. So, and I know that you had some Italian students in Baltimore. So, what about the preparation, the skills of Italian scientists that you have met? What are our strengths and maybe also our problems?
Yeah, I think that it's amazing to see how well prepared and motivated Italian students are. The level of competitiveness is extremely high. So we have a lot of students and postdocs coming through our institution, and they do extremely well. As a matter of fact, I would say that there is a contingent who has decided to stay in the US and has become, distinguished and senior in many, many different universities, not only in Baltimore, but Washington and pretty much all over in the US. So the preparation is there. The interest, the intellect, it's all there. What is missing for them is opportunities. And I think that's where, again, ISSNAF will have a role in helping provided young, meritorious Italian young scientists to connect and find the opportunities that we were lucky to have when we finish studying. So I would say that we have a job at ISSNAF to do this, and I hope we'll see the results very soon.
Right. One question. Do you work not only with Italian universities, but maybe also with Italian companies? Italians are excellent also in the aerospace industry. We have several Italian champions from huge corporations like Leonardo to smaller startups. Do you have an experience of working with them?
I actually have to tell you, Maria Teresa, you were asking me what I did after I finished my studies in Padua. Well, I actually worked in an aerospace industry in Milan for almost a year. And so I have a direct experience of working. After that, I have lost the connection. So if you ask me today, I don't, just because I have chosen a different direction. But I think Italian industries are extremely competitive too, and they play a significant role within the European Space Agency. So I would say that, again, our role is to connect, to make sure that people are connected, that there is a network out there where people can exchange experiences, and also to create and exploit opportunities that appear. So,
yeah. What kind of advice, what kind of things you suggest our young followers to do to go on with a career in this field, in your field?
Follow your passion. And don't let them tell you can't do it. That's, I think, the main message, especially for young women. Just do it. You can.
Great.